Why is this galaxy and many others called impossible? What gave rise to the problem of impossible early galaxies in astrophysics? And the problem isn't just the high mass of these early galaxies, but also the fact is that our understanding of the evolution of galaxies does not coincide with observations. And we will talk about this in this video. You may have already heard the news that a fairly massive barred spiral galaxy has been discovered in images of the early universe. And this fact raises many questions for two reasons. The first reason is that such a massive spiral galaxy should not exist in the early universe. Since the birth of the universe, too little time has passed for this galaxy to have time to gain such a large mass. And to understand the second reason, it is necessary to voice a very important problem of astrophysics. This problem is little known to the general public. It lies in the fact that we still do not know exactly how galaxies are created and evolve. Very little is said or written about this. But our models and concepts of the evolution of galaxies have many contradictions with observations. The results of the simulations hardly reproduce what we see in the real universe. A striking confirmation of this discrepancy between observations and predictions is the fact that, contrary to expectations, the early universe is dominated by disk galaxies. There are many other inconsistencies, which are described in detail in video number 10. And if earlier these contradictions were not so obvious, now our theoretical models are literally shattered. And even preliminary results from the James Webb Telescope signal an impending revolution in cosmology and astrophysics. But such a result could be expected, if you don't turn a blind eye to all these inconsistencies and contradictions. But in this video, I would like to talk about how this galaxy can be explained, even within the Big Bang paradigm, simply by applying a different model of galaxy evolution. Although in this case the age of the universe is probably also too small. In the nearby universe, galaxies of different masses may have a spiral structure and a bar. Let me remind you that about 2/3 of all galaxies are spiral galaxies. And about 2/3 of all spiral galaxies are barred galaxies. But moreover, barred spiral patterns are even present in galaxies that are not spiral. In other words, spiral patterns and bars are, in quotes, the most popular decorative element in our universe. And according to our understanding, galaxies in the early universe should not have spirals and especially bars. And to understand why, you need to get acquainted with lambda CDM cosmology. And according to it, the evolution of matter in the universe looks something like this. Some time after the Big Bang, the matter of the universe was in the form of a high-temperature gas and could not accumulate under the influence of gravity and form stars and star clusters. But dark matter was cold, that is, the speed of its particles was not high, which is the main feature of lambda CDM cosmology. And cold dark matter, in the early years of the universe, began to form clumps. Later, small clumps of dark matter merged with each other and formed larger clumps. Afterwards, the clumps of dark matter with their gravity attracted the cooling baryonic matter. And after several successive mergers, clumps of dark and ordinary matter, something similar to galaxies and protogalaxies, is formed, which subsequently also merged with each other, forming more massive formations. In addition to mergers, the mass of these galaxies increases by the settling of external gas on these galaxies. This process is called accretion of external gas. And thus, through mergers and the influx of external gas, galaxies evolved and developed. This is a short and simplified description. This model of galaxy evolution is called the hierarchical concept of galaxy formation. And according to this concept, all modern massive galaxies were created by the merger of smaller galaxies. But even without going into details, it is clear that such a chaotic merger of galaxies and protogalaxies should lead to an increase in the number of galaxies with chaotic motion of stars. That is, to an increase in the proportion of elliptical and irregular galaxies. But in the modern universe, the vast majority of galaxies have a thin disk with ordered motion of stars. That is, to create the galaxies that we observe in the modern universe. These mergers should not be chaotic, but ordered. And in order to obtain thin stellar disks with a high degree of orderliness of motion, and with a uniform distribution of matter, it is necessary that these mergers occur with a high degree of organization. That is, We need some kind of external arbiter who would regulate these processes. In other words, according to the hierarchical concept of galaxy formation, the thin disks of galaxies are arranged as if they were created artificially. It's as if someone is directing the merging galaxies at the right angle and at the right speed. Let me remind you that spiral galaxies make up about 70% of all galaxies. And if we add to them lenticular galaxies, which also have a disk with ordered motion, then we get about 80%. And it turns out that most of the galaxies in the universe seem to be artificial, man-made. But there is an explanation for this problem, albeit an unconvincing one. Almost all disk galaxies have a spherical subsystem. This is a stellar halo and a stellar bulge. And it is precisely these subsystems that are supposedly the result of these chaotic mergers. But a disk with ordered motion is created as a result of accretion of external gas, which does not fall on the center of the galaxy, and therefore creates a rotating disk. But it is not easy to assume that 80% of the galaxies were created through this apparently artificial scenario. But nothing better was invented. And this makes it possible to turn a blind eye to this obvious contradiction. This contradiction can also be alleviated if we assume that most of the mergers of protogalaxies occurred before the formation of stars from the primordial gas. That is, if first there were mergers of gas clouds, which led to the formation of gas disks, and then stars formed from this gas and the disks. And gas is a collision medium. And in this form, the gas is able to transform from a protogalactic gas cloud into a protogalactic gas disk, just as a star and a protoplanetary disk are formed from a protostellar gas cloud. And the rotation of this protogalactic gas cloud was a consequence of the merger of the clouds that formed it, and also as a result of the rotation of the dark matter cluster in which this cloud was located. But stars are a collisionless medium, which is not capable of so radically transforming its rotation. And the chaotic merging of star systems at different angles will never lead to the creation of a thin stellar disk with ordered movement. On the contrary, physics knows the opposite process. When, over time, due to gravitational interactions between stars, the order decreases and the disk thickens, the entropy of the system increases. This is called warming up the disk. The hierarchical concept of galaxy formation also has a number of other problems and contradictions. Let's return to the sensational galaxy and the essence of the problem. In the modern scientific world, the mainstream opinion is that the cause of the spiral pattern in the galaxy is gravitational instability, which provokes density waves with a special type of orbits. And in some states, these density waves have the shape of a barred spiral. What's the problem here? Why couldn't this bar be in a galaxy in the early universe? The problem is that multiple simulations show that such barred galaxies begin to appear in the universe much later, closer to the middle of the life of our universe, and not at its beginning. Moreover, in simulations, bars are quite unstable and short-term phenomena. And I'll say more. The spiral structure itself in simulations is an unstable and short-lived phenomenon. Of course, you need to understand that simulations are just simulations, and you can change parameters and configure them. And in some cases, it is even possible to obtain massive barred galaxies in the early universe. But nevertheless, these cases are perceived more as exceptions. And it is generally accepted that massive barred spiral galaxies in the early universe are extremely unlikely. And it turns out to be a paradox. In simulations, spiral structures are unstable and short-lived. And getting a barred spiral galaxy in simulations is even more difficult. But most of the galaxies in the universe are spiral. And most of these galaxies are barred. Moreover, we are observing a barred spiral galaxy in the very early universe, where, according to our expectations, it should not exist. And this whole situation gives us more than a hint that our understanding of this phenomenon is fundamentally wrong, and that behind the process of formation of spiral structures with a bar lies a completely different physical phenomenon. But how can the formation of a spiral structure and a spiral galaxy be explained? And how can we explain the existence of this galaxy in the early universe? There are objects in the universe called quasars. These objects represent a galaxy with very powerful oppositely directed jets emanating from the core of this galaxy. Such galactic nuclei are called active. Typically, these jets in powerful quasars consist of particles of matter that move at near light speed. These jets from active galactic nuclei can have different powers. Presumably, these jets come from an accretion disk near a supermassive black hole. In this disk, matter approaching the black hole accelerates, heats up, and some of it, under the influence of very strong magnetic fields, splashes out at enormous speed in the form of jets. This explanation of jets through an accretion disk has a number of difficulties, and some scientists doubt this interpretation. In addition, there are a number of observations that contradict this model of jet formation. For example, precession of jets or a sudden change in the direction of jets and others. This is also discussed in more detail in video number 10. Also, in our galaxy there is a microquasar called object SS433. The acceleration of the jets in this microquasar occurs at a great distance from the black hole, which is extremely difficult to explain within the framework of our understanding of the process of formation and acceleration of these jets. Everything looks as if a completely different physics is at work there. But what if the reason for the formation of jets is not the accretion disk, but some kind of processes inside the black hole or at its event horizon? And what if there is a gradual change in the direction of the jets, but at the same time all the movement remains in the same plane? Imagine a quasar with weak jets, which for some reason began to rotate. Or the magnetic field that determines the direction of its jets began to rotate. This will result in gas in the form of a spiral flowing from the center of the galaxy. And such an outflow of gas has begun to be detected quite often in elliptical galaxies, thanks to the use of the latest telescopes. Over time, for reasons described in video number 10, first a gas disk is formed in the plane of rotation of the jets, and then a star disk. And due to the rotation of the jets, in the same direction these gas and stars will also have the same direction. And the disk formed will be thin, as observed in most disk galaxies. Soon, the disk becomes dense and begins to hide the movement of gas inside. But this gas movement remains visible indirectly. Stars that fall under the stream of this gas, having taken a portion of hydrogen, become more massive, rejuvenate, and begin to shine like newborns. That is, we do not see gas movement in the thickness of the disk, but we see a spiral pattern of bright, massive, and young O and B-type stars. And let me remind you that the mechanism for creating these stars is still not known. And why are they more often found in spiral arms? The pattern of this spiral depends on the velocity of the gas. And if the gas velocity is initially very high, then this section of the spiral is straight, that is, in the form of a bar. In addition, the speed of rotation of the jets can also affect the pattern. And if this speed is very high, then the spiral pattern will be unclear and we will only see spiral waves emanating from the center of the galaxy. And now, such movement of gas in the disk, in the form of jets, has increasingly begun to be detected, thanks to the latest telescopes. All this is described in detail in the same video number 10. But now you should have a reasonable question. Where does this matter in the jets come from? Because the appearance of new matter contradicts the usual understanding that all matter was created in primary nucleosynthesis, during the Big Bang. But you need to understand that these concepts also have their unsolved problems. For example, in primary nucleosynthesis, millions of times more matter and antimatter were created than the amount that is in the universe now. But in the ratio of the mass of matter and antimatter there was a slight asymmetry towards matter. And after the annihilation of matter and antimatter, only a small fraction of matter remains, equal to the magnitude of this asymmetry. But the reason for this asymmetry has not yet been determined. Therefore, primordial nucleosynthesis, like the Big Bang, has problems that do not allow us to consider these hypotheses as flawless. And these problems have recently become even more numerous. Therefore, we will think that in the depths of black holes or on their event horizon, the process of creating new matter occurs. And overall, the amount of matter in the universe is increasing. And perhaps such a thought will seem marginal. But there are a number of studies that indirectly speak of precisely such an evolution of the universe. Simply due to the unpopularity of the results of these studies, they are not covered in the media. As a result, if we assume that the cause of the barred spiral structure is density waves, then for its formation, the galaxy must have a sufficiently high mass. and it takes a lot of time to gain this mass. And accordingly, such a galaxy is considered impossible in the early universe. And if we assume that the cause of the barred spiral structure is gas jets moving in the disk, then galaxies with any mass can have such a structure. In this case, everything depends on the power of the jets and the speed of rotation. And in the early universe, a small elliptical galaxy with an active nucleus could have formed, which over time creates a disk with spiral arms and a bar. But we must admit that even in this case, the discovered barred galaxy is too massive to have formed since the Big Bang. And this applies not only to this galaxy, but to a large number of massive galaxies in the early universe. Therefore, the problem of impossible early galaxies appeared. Moreover, a recent study has shown that the proportion of spiral galaxies in the early universe is significantly higher than we expected. Therefore, our models and theories are literally shattered against objective reality, which tells us that our understanding of the evolution of galaxies and the evolution of the universe is not true. And it's time to reconsider our theories.